So let's solve the numerical problems here. What is the momentum of an electron of kinetic energy and an electron volt? Here kinetic energy of the electron is given and we have to calculate the momentum. So the mass of the electron is known, 9.1 into 10 to the minus 31 kg. Kinetic energy of the electron is 100 electron volt. So we can calculate the kinetic energy of this one is half mv square is equal to 100 electron volt. So we can convert this one into this value. Momentum is equal to the kinetic energy into 2m. So here the 2 get cancelled and m square into v square square root, that gives the mv value. So on substituting the value of 2 into 9.1 into 10 to the minus 31 kg, that is the mass of the electron, and also the kinetic energy, we will get 5.39 into 10 to the minus 24 kg meter per second. So in this billiard ball A moving with velocity 1.2 meter per second in the y direction and strikes an identical ball of B initially which was at rest with a velocity 0.56 I plus 0.80 j meter per second. Find the final velocity of the B. So we have to calculate the V2. So U1 is known, 1.2 meter per second in the y direction, that is 1.2 j meter per second, and V1 is known, that is after collision it is moving with this velocity. So here two balls, one is A and one is B. It is ball B. So after striking this one, so this moves with the velocity 0.56 I plus 0.80 j meter per second. B was at rest, then E2 is equal to 0. So from the conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Since mass is same on both sides, we can cancel the masses and u2 is 0, so we will get this equation. So now 1.2, that is U1 is known, 1.2 j meter per second is equal to 0.56 I plus 0.80 j meter per second, and this velocity 2 should be calculated. We will get for about 0.56 I plus 0.40 j meter per second. In this problem, an object of 0.3 kg moving with velocity 10 meter per second undergoes a one-dimensional elastic collision with the particle of 1.5 kg. So it is, the second particle is 1.5 kg and the first particle is 0.3 kg. Okay, so when it undergoes the one-dimensional elastic collision, so this particle is moving with velocity 10 meter per second, and also this particle is moving with velocity 4 meter per second. This is the velocity and this is the velocity of the second particle. So what is the change in kinetic energy of the 1.5 kg object? Is the 1.5 kg object, that is 4 meter per second, and the final velocity is to be calculated. So the final velocity is considered as V2 and the initial velocity of this particle is considered as E2. Now the change in kinetic energy is of m v2 square minus u2 square. So this is the change in kinetic energy. So here the final kinetic energy of the second particle and the initial kinetic energy of the second particle. V2 is equal to, that is the velocity of the second particle after collision is 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. So it is the equation taken from the one-dimensional elastic collision. So then on substituting the values, we will get 6 meter per second. So the change in kinetic energy is of m into v2 minus u2 square. Then we got the value of v2 6 meter per second. Then on substituting the values, so we'll get the value of 15 joule. In this Initial mass of the rocket is given 100 kg and the final mass of the rocket is given, that is 10 kg. If the velocity of the exhaust vapor relative to the rocket is 2 km per second, then find the maximum speed attained by the rocket. So initial mass is given, that is 100 kg, and final mass is given 10 kg. It is not 1 kg, it is 10 kg, and then velocity is 2 km per second. So the initial mass of the rocket is 100 kg. 100 divided by the final mass of the rocket is 10 kg. Now it is, we have 10. Now the final velocity of the rocket is equal to v naught plus v relative into log m naught by m is equal to, so the initial velocity is considered as 0, and then the relative velocity is given 2 km per second, log 10 is 1, and then we can convert this log e into 2.303, so we will get 2 into 2.303 is equal to 4.6 km per second. So in this problem, the carbon and oxygen is at a separation of 1.12 angstrom. Find the center of mass of CO molecule with respect to the C atom. The distance between two atoms 1.12 angstrom. Let x1 coincided with the reference frame, then x1 is equal to 0 angstrom and x2 is equal to 1.12 angstrom. Then the mass of carbon is equal to 12 units, that is atomic mass units, and O is equal to 16 atomic mass units. Then xCOM is equal to 12U into 0 angstrom plus 6 units into 1.12 angstrom by total mass, which is equal to, so we will get this term as 0, and then we have the answer of 0.64 angstrom.